Okay, so first we're going to talk about how the inputs are taken in from the keyboard. So there's a couple modules that do this. The first is this keyboard module that receives PS2 input.
That we're using to receive data from the keyboard is this PS2 receiver module. And from that, the inputs into that are the PS2 clock and PS2 data. And essentially it's taking the 8 essential bits. Can you scroll down a bit more? And you can see here in the always negative edge of K clock, it also it debounces the data that's getting inputted in the clock and the K clock and the K data F. Basically taking the 8 essential bits. That's why it's doing case statement, and those are the 8 bits actually represent actually represents what's being pressed on the keyboard. Other 3 bits are like parity bits, start and end bits. So based on those 8K data bits, we're also cycling it through a 32-bit register called key code. So the key code is the main output from this PS2 receiver.
Just say that the key code is 32 bits, but the last 8 bits are assigned to this short code.
There, and then in the scanned keys, using those 8 bits, we are using a really long case statement, and basically the whenever it's like we're converting it between the PS2 convention into essentially like a 1-bit encoding, and
We'll talk about a little bit about how the entire game functions.
Okay, so the first thing we can talk about is the Getstate module, which sort of acts like the conductor, so to say, for all of the other modules. And it's got a lot commented out, but here down at the bottom, you can see that it fundamentally functions based on the enter signal, which we had originally intended it to be a signal that goes high when the enter key is pressed, but we had to discard that and use a button on the FPGA instead, but it works the same way. And based on our state diagram, it starts on like a start state, and then it has a player 1 place and player 2 place state that it cycles just by adding 1 to go to each state in a sequential manner when the enter button is pressed. But then once we're in the firing states where like player 1 and player 2 are taking turns, you can see from line 66 that it instead just kind of cycles between states 3 and 4, which are player 1's turn and player 4's turn whenever the enter key is pressed. And Jong and I wrote this module together. Like we got, for really all of the game logic modules, we were like on a Zoom call writing them together. So next, we can talk about the set shifts module. Jong, if you want to discuss this.
Set shift module, what it does is basically takes the inputs from the keyboard and it compiles it into a 1 register. So if you can see, one of the inputs is pressed keys, and what it does is it takes that 1 hot 36-bit keyboard input, and then it outputs to a 36-bit chips register. And we did that by indexing individual keys into a 36-bit register.
And then last, we can just talk about the hit or miss module. This is the one that controls whether players landed a hit or not. You can see it it makes a copy of the enemy ship locations when the ships are being placed. And then when the fire signal goes high, which is simply a signal to let, based on this, the get state module that lets this player know that it's their turn, it evaluates whether the key being pressed has the same, from our 1 hot encoding scheme, has the same bit mapping as the ship locations. And if so, it takes that copy of the ship locations and sets that spot to 0 to indicate that that ship is destroyed. And then if any hit was made, it sends out a hit signal high to indicate that there was a hit, so that can be displayed on the VGA. And then once that copy of the ship locations is all zeros, that's what indicates that the game is over, because that means that all the ship locations have been hit by that player. And last, if you could just go to the top module, you can see that we have a very like sort of neat organization in here with the top module, and that we basically just took all of these modules and wired them together in the appropriate manner. And I believe that's it for our code.
Okay. So the last bit of our code is how the outputs are displayed. So all of that logic is in this displays in keyboard module. The first, so the keyboard we've already discussed, but the other aspects to our code are the 7-segment display letters. And so the 7-segment display control takes in player 1 fire, player 2 fire, which correspond to player turns, and then player 1 place and player 2 place, which correspond to when players are actually selecting their ships. And Kenneth wrote this modules, but basically when player 1 place is high, the 7-segment display displays P1 place. When player 2's place is high, it displays P2 place. When P1 fire is high, the 7-segment display shows player 1's turn, and then for P2 fire, it shows player 2's turn. And for any other case, the start, like when the game first starts up, the 7-segment display just displays Battleship. The other output is the Vga output. So the Vga is implemented with a clock divider, a horizontal counter, and a vertical counter. And I wrote this code, and I have different modules for every screen. So I have a hit screen, I have a miss screen, I have a start screen, and a screen for player 1 wins and player 2 wins, and then a default screen, which is just plain red. So basically what these modules do is they take in H counter and V counter, and then they output a different color depending on the value of H counter and V counter. And then all of the displays are muxed together based on the screen number. And the screen number is determined based on hit or miss, and then also whether a player wins, and a start input. So all of these inputs output a 5-bit 1-hot screen number, which then determines which screen is displayed on the Vga screen. Okay, Battleship. We can start. I'm gonna press this button to start. Right? Now it's player 1's turn to place some. I'm player 1, I place some ships. 0, A, H, and K. And now it's player 2's turn. And player 2 is gonna place K, 5, and K. Now it's player 1's turn. Player 1 is gonna press M, or press 6, right? We missed. Player 2 is gonna press K. We hit. Player 1 is gonna press O. They missed again because they're really bad at this game. Player 2 is gonna press T. Missed. Player 1 is gonna press F. We missed. Player 2 is gonna press A. Yay, we hit. And then player 1 is gonna press 5. We hit. Player 2 is gonna press H. We hit again. And then player 1 is gonna press 7. Missed. Player 2 is gonna press 2. Missed. Player 1 is gonna press 9. Missed. Player 2 is gonna press 0. Player 2 wins. So that's a basic little description about how our game works. I think most of the functionality is there. The only other thing would be showing how player 1 could win. So now player 1 places. I'm gonna place a couple ships. Player 2 places. Not gonna press any ships for player 2. Player 1's turn. Now player 1 wins. So that's what our screen looks like when player 1 wins. And yeah, that's it.
We're good?
Yeah. I guess I'm gonna just explain a little bit about how the game works now. I think you can splice this into the beginning, right? So basically how the game works is that when you press the enter button, player 1 can place any amount of shifts they want. So I can just press all the buttons I want, and then all those keys pressed become your ships. Now it's player 2's turn to place. They can also press as many buttons as they want. And then the game starts, and each player presses one thing before the next player's turn. And eventually, one of the players will win. That's it.